Hello, good afternoon, everyone. Um, since we are waiting for a few people, I'll say hello, Philemon. Hello, Abdul Hafiz. Hello, Benjamin. Um, you guys are all welcome. We have a lot of people tuned in now, so I'll jump straight into it. So, welcome everyone to Coding 101, coding skills for beginners in a digital economy. This will be an introduction to coding, and I'm going to be using Python. Um, so my name is Kwesi Amankwa. I'm a solutions architect, machine learning operations at DataWare Ghana. You can see our website there. You can check us out anytime you'd want to. This is how it's going to be. I'm going to take you through why we program, take you through some puzzles and syntax. How do we talk to the computer? And then we do an introduction to Python itself. And then I give you some tips and conclusions on coding, maybe some tips to help you out later. So why do we program? Basic. Computers are dumb. They can do things very fast, lightning pace, but they are dumb. And so you have to speak to a computer. I say computers are all brawn and no brain. And so you have to instruct the computer as to what to do. Let's say a computer is an assassin. A computer can kill people without them realizing it. Now, who is the computer supposed to kill? You are the one as a programmer who instructs the computer, okay, kill this person, and the computer executes it perfectly. And so programming is the art of instructing a computer. Um, I don't know if any of you have come across this puzzle. Um, where there's a river, you have to get the whole family across the raft. Um, Now you have a police officer, a thief, two boys, a dad, mom, and two girls. Now the rules of the game is that at most two people can be on the raft at once. You will need at least one adult to operate the raft. Yeah. Um, Apart from that, the policeman can't leave the criminal with other people, and you can't leave the father alone with any of the girls, as well as the mother with any of the boys. Now, these rules are supposed to be followed, but you know, following these rules, you should get everyone across the river using just the raft. This is the answer, the basic answer. The police officer and thief will go first. The police officer leaves the thief there, comes back. Three police officer and the boy go. Now you leave the police officer and the thief come back, leaving the boy at the other side. Dad and boy one comes back, leaves the raft. Dad and boy two go. Boy two is left there. Dad comes back. Dad and mom go. Mom comes back. And so when you look at this, this gives you a format of how you are supposed to go across the river using the rules that you have been given. We call this syntax. It's the same in programming. When you have a language, every language has syntax that you follow. And so whatever that you do is guided by this syntax. You would want to note that syntax. Now, how do we talk to the computer? As a programmer, you give instructions, as I said earlier, and you have a translator that translates everything you do to the computer. And so you say you are supposed to do A, B, C, D. The computer speaks another language. We call it machine language. And so the translator takes what you say and puts it in machine language for the computer. Now, as a programmer, you don't just write your code anyhow. You have your source code written and edited in particular spaces. We call them editors. An editor is normal notepad on your computer is an editor, yes, but you would want an editor that is kind of intelligent. So most editors we use have colors attached to them, and so when you do some things, you know that okay, this block has this color, this block has this color. It helps you to put things in order when you are coding, else everything will just be a mumble jumbled up for you. Now your translators, you have compilers and you have interpreters. I mentioned translators earlier. They take what you say in the programming language and then they convert it into computer language. Now an assembler does the real thing, but the difference between a compiler and interpreter is a compiler takes your whole code, goes through everything, and if there are errors, spits out the errors before speaking to the computer. Now, an interpreter takes one line, each line of your code, um, interprets every line, speaks to the computer, comes back if there's no error, takes the next line, speaks to the computer, comes back if there's no error. And so you have the compiler and interpreter being different in such a manner. They both have the advantages and disadvantages. And we wouldn't want to go deep into that now. Just know that for computer translators, you have compilers and you have interpreters. Python programming uses an interpreter. And so for Python, we will be using an interpreter instead of a compiler as a translator. And now we have integrated development environments. Now, these are environments created for you, right? These environments contain editors, they contain translators, they contain debuggers. So debuggers are kind of troubleshooting within programming language. If there's error within your code, you are able to see it, and then debuggers will help you find these errors quicker. We are moving straight into Python. Now, what you do, why Python? To start with, Python is free, it's open source. And so who doesn't like free stuff? We all want to do something. When it is free, it's so nice. Python is versatile, right? And so programming is not just development. Let me put this straight. When you are coding, you are not every coder builds a computer game or some strange stuff, right? Sometimes you have mathematicians coding whatever that they want to, whatever maths that they are doing, because they want to visualize it. You have different types of programming. Even people who use Excel program in Excel. And so Python is kind of versatile. Some programming languages are limited to certain jobs, and others are limited to quite a number. So C is mostly used in legacy systems, but you have Python being so versatile. You can use it in machine learning, you can use it in web development, you can use it for so many things. Easy syntax, like I mentioned earlier, most of the rules in Python are very free. They are not quite cumbersome, and you have a huge support community. You have people who are always available to help you with any problem that you come across when you code in Python. Your first code. Now, you have A equals to, what you have in yellow is going to be your first code. Then I'll take you through variables assignment, data types, arithmetic operators, decision-making functions, and reserved words. The first thing you are going to learn in Python programming are variables. Now, you've been coding since primary, probably even kindergarten. When I say this, people don't get me. Now you see what I have on my screen, where there's a box plus 5, which is equal to 10. Now, that's what you are given in primary. Everyone knows that the box means something is supposed to be there, and it should fit the whole equation. When you get to GSS, moving to SS, we call it algebra, where the box is now replaced with an X. And so you have, instead of box plus 5 is equal to 10, you have X plus 5 being equal to 10. And so if I'm to put this into something clearer for you, the code that I had earlier, A is equal to 2. Let me stop using equal to because it might confuse you. So I'm putting 2 in A, putting 3 in B. Now you have C being a combination of A and B, right? And so you have A being a variable, which is the box here. You put 3 in B, B being your pentagon here, and then you add the pentagon and the square, and you put that in a triangle. That is all that the code in yellow is doing. You put 2 in a variable A, you put 3 in a variable B, you add variable A and B, and then you put it in C. Now, it is a variable because it can change. I use put in because it is an assignment. Now, equal to, the equal to sign there doesn't mean equal to. It means you are assigning a number to a variable. And so just note this, we'll get there later. Syntax for naming variables, right? for your variables, you have certain ways that you can name them. A variable must start with a letter or the underscore character. The underscore is the thing that I have after the end. Sorry, I have a baby in the house. A variable name cannot start with a number. You should note this. A variable name can only contain alphanumeric characters and underscores. I think I've listed that already. And variable names are case sensitive. That means the uppercase and lowercase create different variables. So you might have three variables with the name age, right? All of them have age as being the variable, but there are three different variables because the second age has a big A, and the third age has all the letters in it being capital letters. And so you have three different variables that you can assign three different numbers to in this way. Data types. Now, the data that you put into a variable, right? You have 5 types of data that you can put into a variable. You have numbers, you have string, which we will call letters. We have list, tuple, and dictionary. I would want to switch. Let me switch to just a moment. I would want to switch quickly. I want to code live for you so you experience what we are doing. Okay, I believe everyone can see this now. So here we are. We have this is an integrated development environment. This is called Jupyter. I'm using Jupyter because you can I want most of you to see I want most of you to see just what the output of whatever that I'm doing. And so for Jupyter, when I run every line of code, you are going to see the output just below. We talked about assignments earlier. And so now I'm looking at numbers. Numbers are the first data types that you can put into a variable. Here I'm putting in an integer for counter, and I'm putting in a floating point number for mouse. Now, difference between an integer and floating point is that floating points contain decimals. So 1.3, 3.4, these are floating points. 1 is an integer, but if you want to make 1 a floating point number, it is now 1.0. So 1.0 is a floating point and 1 is an integer. Now I have made the assignment, and then I'm going to print out counter. The print statement outputs whatever variable you put in there. And so print counter, you realize that the output here shows 100. That means that the variable counter now contains the integer 100. Print mouse. Now, I put this here because I wanted you to see what a syntax error is. I told you there are rules that govern what we do. And so the rules for using a print statement is that everything must be in parentheses. The variable that you are printing out must be in parentheses. And so you have mouse not being in parentheses, and you have your syntax error here telling you that missing parentheses to call print. And so fixing that, all I'll do is add parentheses here. I run the code, and now we have our floating point number showing as 1000.0. Now, apart from numbers, we have another data type called string. Like I told you, strings are like letters. And here, for strings, when you are assigning a string, you can put them in double quotes or single quotes. And so I'm putting John in double quotes here says that the name variable, I'm assigning John, the string John, to the name variable. And so I make that assignment here. Let's say I wanted to print name, the variable name. I print it out, and we have John coming out as our output. Now, this is the difference between integers and strings, or numbers and strings. The string is equal to 100, like I put there. It is a string. It is 100, but it is a string, as in letters, when I'm writing 100. When I have integer, it is a number. So I can add numbers, but strings, I can only concatenate them. Where concatenation means, say, if I have a form and I have first name and last name, if I concatenate it, I have a full name. And so I have first name plus last name giving me a full name. That is called concatenation when you are dealing with strings. But if you are dealing with numbers, you would want to use arithmetic operators, which is a plus is not a concatenation. but it is addition. And so if I do 5 plus 3, it is not going to give me 5, 3, right? It is going to give me 8. But if I have 5, which is a string, plus 3, which is a string, it is going to give me 5, 3. I I would want to show you that here. And so let's say string 2 is equal to 50, right? Now if I'm to concatenate this, I'll say print a concatenation of the string and string 2. The output gives me 10050, right? And so you realize that it's just put them together. It didn't add them. If I do, let me put a space here so that you see more. I've put a space there, and so I run this, and you realize that there's a space coming in between the 100 and the 50. And so it is just taking what is in this variable, what is in this variable, and just joining them. If I wanted to make these integers, I make them 100. I've taken off the quotes. Just remember, we are dealing with numbers now. And then I print this. We have 150 because I'm doing an addition and not a concatenation. Now, I put the types here because I wanted you to see the types of strings that we have. So let me put 100 back, right? I've put 100 back as a string. And so I print out the type, and the class there shows str, which means string. If I print out the type for string 2, which I've assigned a number, you see the class there is integer. I can do this 5.0, and then I'll print out string 2, and it shows me that it is now a float. And so now we know the difference between numbers and strings, and even within the numbers, we know the difference between an integer and a float. Now you go on and you move on to lists. Lists are the third data type that we have. Now lists are in this form. You have the list variable name, which is assigned parentheses, and then you have whatever that you want to assign in there. So when you want to assign, say, a group of objects into one, you call them. So let's say you want to, a list is like a trotro that you put people in. And so if you wanted, say, strings and numbers that you wanted to put all of them together as one variable, right? You put all of them here into a list, and you have them like this. Now I would want to reference something for you so that you see. When you go to the data types for a list, when you are referencing a list, you have our list here being the list name. And then, like I said, it is like a trotro. So you have them within the list object, but they are separated. Now, the first object in there is A, second is B, third is C, fourth is D, and fifth is E. If you wanted to refer to A, you do our list parenthesis 0. Now, this gives you the first element within the list, which is equal to A, or which is A. This gives our list 1. Now, so in programming, mostly when you are numbering something, you start from 0. And so although we are usually used to 1, 2, 3, for programming, we start with 0, 1, 2. And so if I say our list 0, our list parenthesis 0, I'm referring to the very first element within the list. If I say our list parenthesis 1, I'm referring to the second element within the list. And from what I'm showing you, you see that it is A and B, respectively. Now, I would want to print out this list for you to see. I've assigned all these things to the list variable, and so I print them out, and you see that, yes, it prints out the list for us to see. Like I said earlier, print list 0. For the list that I assigned earlier, A, B, C, D will give you your first element. So print list parenthesis 0, the first element of the list. You have A, B, C, D being shown in the output. List 2, which is the third element. Remember, the third element from our list, we have A, B, C, D, 7, 8, 6, 2.3. So 2.23 is supposed to be our third element. You see that in the output below. And then minus one. Minus one is always the last element in the list. So sometimes you have a very long list. You wouldn't want to look at the very last thing within the list. And so you just put minus one. And from our list that I gave earlier, 70.2 is the last element. Tuples are like lists. Just note this. It is the parentheses that you use for tuples that change when you come to tuples and lists, right? So tuples are lists, but they are read-only. That means when you do the first assignment for a tuple, you cannot change whatever you've assigned again, right? And so just like the list, we have the tuple here. And what it shows us is the same output for the list, because I put the same things within the list within the tuple. The main difference between a list and a tuple is that one, the brackets that you use. For a tuple, I use these type of brackets, and then for lists, I use these types. So recognize them. Now I want to show you the difference here. Here we have tuple diff, list diff being the variable names, and I've done the assignments already. If I do tuple diff is equal to 100, I'm assigning a new element to tuple diff, right? So this will be the third, I'm referring to the third space within the tuple, and I want to change it from 2.23 to 1000. It is not going to work because with tuples, you can't change a tuple once you've done the assignments. But if you come to a list, it is going to work, right? It is going to work. And if I'm to put print list diff 2 here now, initially the third element within the list was 2.23, but now I've done a new assignment. I do this and you find out that the third element has now changed to 1000. And so between a list and a tuple, they are basically the same, but a tuple you cannot edit after you've made the first assignment, and a list you can edit after the assignment. Now, the last data type that we have, if you look here, is the dictionary. I would want to take you through the dictionary quickly. So a dictionary uses a key value pair. Now, when you go to Opoku school, you don't refer to students with their names. They are given numbers, and so any person within Opoku school calls their mate 5510, 218, 310, and when you have the person's number, you can find out the person's name, the person's age, the person's class, and everything from that number. And so that number given to that person is like the key for that person. And then the other details that you find out about the person becomes the value. And so Opoku school uses a key value system for identification. A dictionary, does something similar. So a dictionary does something similar where you have your key being key 1 value 1, 222 being your key, and then your value being value 2. And so when you want to make reference to stuff within a dictionary, you use the key, right? Here I've assigned name, code, department as keys, and then the values being John 6734 sales. And so I list out the keys, and you have name, code, department showing down here. I list out the values, and you have John 6734 sales. And so if I wanted to find out about, say, what is the department of John, I'll just mention, let me just do this for you so that you see. I'll just mention the dictionary variable name. I'll just mention the key, which is department. And we have sales popping up. So we have sales popping up as the value for that department. Now I want to show you operators also. Like I said, operators, the equal to sign is an operator. It is an assignment operator. So A equals 10, B equals 10, A equals 10, B equals 20, C equals 3. They are assignments. And so I've assigned 10 to A, 20 to B, 3 to C. So if you use other operators, now if I do A plus B, let me do this, and now I do A plus B, I have 30 showing up, which is 10 plus 20. A minus B, I have minus 10, multiplication, A times C, I have 30. Division, now modulus is if it's the same as mathematics, and so I have B modulo C, which is 20 modulus 3. If you've done some mathematics, you know that 20 modulus 3 is 2. Exponent A exponent C, which is 10 exponent 3. This should give you 1,000 if my math is correct. And then you have comparison. So now you have equal to showing up. If you want to do equal to, you use the equal to twice. And so if I say A equals B, I see it show here as false because A is 10, B equals 20. If I say A is not equal to B, I have true because 10 is not equal to 20. A is greater than B, false because 10 is not greater than 20. A is less than or equal to B. It is true because 10 is less than or equal to 20. It is less than anyway. And then the final thing I'll teach you are functions. So functions use the same things that we do in mathematics, right? So in decision making, I'll take you through decision making. Functions are like mathematics, right? You do 2x plus 3. Y is equal to 2x plus 3. And so if x is 1, y is 5. If x is 2, y is 7. If x is 3, y is 9. When you do this, you have your function. So the code is in yellow. You have your function, and then you put an argument within the function, which is your x. And then you have your answer coming out of the function. And so if I'm to show you what functions do here, you see our function x. Now within the function, you have y is equal to 2x plus 3, and it returns y. Returning is the answer it brings out. And so if I put 3 in there as our argument, 2 times 3 is 6 plus 3, which should give you, which should give you 9, right? And then the final thing I'll teach you is decision making. Decision making is, so you have a condition. If it is true, you do A. If it is false, you do B. And so you have an if statement. If condition is true, execute this code. So if you have condition A being true, you execute. If you look at the if else statement, if you have the condition being true, you execute A. The else is the alternative that is executed if the condition is not true. So if the condition is true, you execute A. If it else, you execute B. Now you have if else, if elif else. Now that has more than one condition. So let's say if you have condition being true, you execute this, or you have the condition being another thing, you execute this. And if all your conditions don't fit the stated ones, you execute the last code. That's kind of the final thing we are doing. I've assigned A as 5, B as 7. And so you have if A is less than B, print A is less than B. If LF or else if A is equal to B, print A is equal to B. Else, if all these conditions are not met, print A is greater than B. Now A is 5, B is 7, and so we know that it is going to print out less than. If I make A greater than, it prints out A is greater than, because when it checks the condition, it sees that A is not less than, A is not equal to. So the one that is left for it to execute is A is greater than B. And so you have that being your functions, being your decision making. And however you'd want to control that depends on you. It all depends on the syntax. Now you have some reserve words that you use. These reserve words that I've listed out here, don't worry, we will give you the slides later. They are like words within the computer that show what you are doing. So else, if, elif, all these are reserved words. You can use any other word within programming, but you can't use them because they've been reserved for the programming language. The website I've put out there is the website you can go to if you want to install Python on your computer, the translator, like I said, if you want it on your computer so that you can be able to start coding and talking to your computer. When you go there to teach you. Now, don't chew and pull. Every programming language has documentations. I'll advise you to read them, know the rules, know the syntax. Don't chew them, just know them, be familiar with them. And when you want to practice, you practice by editing out bad code. If there's some code that the people will tell you there's an error with this code, just take time, look through the rules, look at the bad code, try to find out what is wrong with it. And that is how you get better with coding, not by chewing and pouring. All those things you see in movies are false. It's not how you actually program. So I would like to thank you. Um, at this point, I'll ask for questions. We've rushed through this as much as possible, but I've taken you through all the basic paradigms you need in starting any programming language. That's my email address. That's my LinkedIn name. You can contact me anytime, and then we can get talking. Thank you very much. Okay, guys, I would expect questions now. Let me check. Thank you very much, Emmanuel. Thank you very much. Okay, Michael, the Jupiter, I used the dark version. Sorry, I should have used maybe a light version. I myself, I wear glasses. I didn't take that into consideration. As a beginner, where do you start to learn how to program? Okay, Yaira, there are sites available. I started with Khan Academy on YouTube, but there's Code Academy. These are online platforms that teach you how to code. Code Academy, Coursera, edX, Udemy. There are a lot of free coding tutorials there that you can use. On YouTube, I use Khan Academy. Khan Academy does great when it wants to break things down for you. And so, yeah, I'll advise that. Thank you very much, Enoch. Thank you very much. Isaac, I think I took Yaira through Khan Academy on YouTube. For a beginner in Python, for now, you would want to choose Visual Studio Code, VS Code for short, Visual Studio Code. Jupiter is more for machine learning. I do machine learning a lot, but you would like to use Visual Studio Code. It makes a lot of things easier, and it's free to. It's Microsoft holds that, and so you would want to use that. I hope that answers your question, Jessica. All right, it seems my time is up. Thank you everyone for joining my session. I hope you enjoyed it. Like I said, you can contact me anytime you would want to. I'm always available to help. Kwesi gmail.com. Just send me a message and I'll get back to you. Yes, Khan will take you to the basics. Khan is very, very good. Khan will take you to the very basics. Training facilities, like I said, Code Academy, Udemy, Coursera. If it is hands-on, if you would want to do hands-on training, there are a lot of schools around that do that. Just send me a message. Yara, send me a message on LinkedIn and I'll send those ones out to you. So thank you everyone once again. I hope we get in touch. Thank you for making this session very successful.